An application service registered with the singleton lifetime will be created only once during the lifetime of the dependency injection container. In ASP.NET Core, this is equivalent to the lifetime of the whole web application. The first time the service is required, the container will create an instance. After that, the same instance can be reused and injected into all dependent classes. The instance will remain reachable for the lifetime of the container, so it does not require disposal or garbage collection. Suppose the service is required frequently, such as per request. This can improve application performance by avoiding repeated allocation of new objects, each of which may require garbage collection only moments later. Additionally, if the object is expensive to construct, limiting this to a single instance can improve your application performance, as it only takes place one time when the service is first used. When choosing to register a service with the singleton lifetime, you must consider thread safety. Because the same instance of a singleton service can be used by multiple requests concurrently, any mutable state without suitable locking mechanisms could lead to unexpected behavior. Singletons are very well suited to functional style services where the methods take an input and return an output, with no shared state being used. A reasonable use case for the singleton lifetime in ASP.NET Core is for the memory cache, where the state must be shared for the cache to function. When registering services as singletons, consider the implications of a single instance remaining allocated for the life of the application. It's possible to create memory leaks if the instance holds large amounts of memory. This can be especially problematic if memory usage can grow during the instance's lifetime, given that it will never be released for garbage collection. If a service has high memory requirements, but is used very infrequently, then the singleton lifetime may not be the most appropriate choice. We can switch to a singleton registration by changing our code to call the addSingleton method. This has the same signature as addTransient and is a simple modification. When we run the application, the homepage loads, and after one request, the same GUID is found in the middleware and the page model. If I make a second request, the same GUID continues to be returned. This is because a single instance of the GUID service is created during the first request. Subsequent requests also get the same GUID service. Scoped services sit in a middle ground between transient and singleton. An instance of a scoped service lives for the length of the scope from which it's resolved. In ASP.NET Core, a scope is created within your application for each request it handles. Any scoped services will be created once per scope, so they act similarly to singleton services, but within the context of the scope. All framework components, such as middleware and MVC controllers, get the same instance of a scoped service when handling a particular request. Because the container resolves a new instance of the type per request, it's not generally required to be thread safe. Components within the request lifecycle are invoked in sequence, so the shared instance is not used concurrently. Scoped services are useful if multiple consumers may require the same dependency during a request. An excellent example of such a case is when using Entity Framework Core. By default, the DB context is registered with the scoped lifetime. Change tracking therefore applies across the entire request. Multiple components can make changes to the shared DB context. Any services that depend on a scoped service should themselves be registered as either scoped or transient to avoid the object being captured beyond its expected lifetime. We can update the sample application once again, this time registering the GUID service using the scoped lifetime. After saving this file, we can start debugging the application. After the first request, the same GUID is shown from both the middleware and from the Razor page. As each was invoked during the same request lifecycle, they receive the same instance of the GUID service and therefore have access to the same GUID value. If we make some new requests by refreshing the browser, each has a new scope. So while the GUID appears the same between the middleware and the page model, it's a different GUID for each request. When registering your dependencies, it's crucial to ensure that the chosen lifetime is appropriate, considering any dependencies that the service has of its own. This is necessary to avoid something called captive dependencies, which is where a service may live for longer than is intended. A service should not depend on a service with a lifetime shorter than its own. For example, a service registered with the singleton lifetime should not depend on a transient service. Doing so would result in the transient service being captured by the singleton service, with the instance unintentionally being referenced for the life of the application. This can lead to problematic and sometimes hard to track down runtime bugs and behaviors, such as accidentally sharing non-thread safe services between threads or allowing objects to live past their intended lifetime. To visualize this, let's consider which lifetimes can safely depend on services using another lifetime. Since it will be a short-lived service, a transient service can safely depend on services that have transient, scoped, or singleton lifetimes. Scoped services are a little tricky. If they depend on a transient service, then a single instance of that transient service will live for the life of the scope across the whole request. You may or may not want this behavior. To be absolutely safe, you might choose not to depend on transient services from scoped services. But it is safe for a scoped service to depend on other scoped or singleton services. A singleton service is the most restrictive in terms of its dependencies, and it should not depend on transient or scoped services, but it can depend upon other singleton services. Capture of scoped services by singletons is one of the more dangerous possibilities. Because scoped services could be disposed of when the scope ends, it's possible that the singleton may try and access them after their disposal. This could lead to runtime exceptions in production, a really bad situation. We can explore the effects of captured dependencies by using our sample application. The application includes a page named trimmed, and the model for that page depends on an iGUID trimmer in order to provide a trimmed GUID value. The GUID trimmer is a simple service which removes dashes from the GUID string. The GUID trimmer depends on an iGUID service to retrieve the GUID that it will then trim. This is of course a trivial example, but it's sufficient to understand the problem at hand. Let's register this service with the container, and we'll use the singleton lifetime here. Now, perhaps alarm bells are ringing in your mind already. Do you think this is a safe service registration lifetime to choose here? I'll run the application and we can see what happens. That's interesting. An invalid operation exception is thrown when the build method is called. The message states that we cannot consume a scoped service, in this case the iGUID service, from a singleton service, the iGUID trimmer. Our current registration causes the singleton service to capture a scoped service, and as we've discussed, this can be dangerous. So we're warned of this danger by this runtime exception. In ASP.NET Core 2.0, a feature was introduced called scope validation. This is enabled by default when the environment is set to development. It validates the container configuration to ensure that no scoped services are captured within singleton services. When enabled, validation will occur at application startup when the build method is called. If any captive scoped services are identified, then a runtime invalid operation exception will be thrown, as we just saw in the previous demo. I'm going to change the launch settings for the sample application to illustrate an important point about scope validation. I'll change the ASP.NET Core environment variable, which is applied when running the application from Visual Studio. I'll temporarily set it to production, and I'll rerun the application by pressing F5. This time the home page loads and we no longer experience an exception. The scope validation feature is not enabled in the production environment by default, since it may have performance implications. Even though we don't experience the exception, this doesn't mean everything's okay, simply that we're no longer being warned about the misconfiguration. The GUID trimmer still captures our scoped GUID service. We can see this by visiting the trimmed page URL, where a trimmed GUID is displayed. If I refresh the page, the GUID does not change. Even though the GUID service is registered as scoped, meaning a new instance should be created per request, the GUID trimmer has captured an instance into its private field. Because the GUID trimmer is a singleton, it's only created once, and therefore it always uses the same instance of the GUID service that it captured. I'll switch the application back to running under the development environment. We can change the behavior of scope validation by configuring the service provider options. To achieve this, we can access the host from the application builder and call the use default service provider method. ASP.NET Core calls this method itself, but we can configure some extra options if we choose to call it ourselves. We can use a Lambda to configure an action used to modify the default options for the service provider. We can explicitly enable or disable scope validation by setting the validate scopes property. If we disable it for demonstration purposes and then rerun the application, again, we'll not experience the exception, even though we are back in the development environment. As a rule, you should not modify this option without good reason. The exceptions during development are beneficial to avoid invalid service registrations and the accidental capture of scoped services. The proper fix for this sample application is to register both services with the same lifetime. We could make them both scoped, or, since neither has mutable state and therefore is thread safe, we could also make them both singletons.